So, everyone, please welcome Jens Stegemann and Jan Weidenhaupt, sorry guys, from Öffentliche Insurance. And yeah, Jens is a head of IT architecture and data analyst, and Jan is an application engineer at the firm, and they will be talking about making a chat app, which is a PWA and made with Fritz and Kotlin. The stage is yours, guys.
Yes, thank you. Hi, and welcome to our talk about building reactive web apps in pure Kotlin. At first, I want to thank you for the chance for us to talk to you about fritz2. It is a project that we started about a little more years ago at the company we are working for, and it's the very first open source project our company ever did. So it's still quite exciting for us to work with different people on this project to get a lot of feedback. And I hope you will enjoy what we try to show you today. And we will enjoy what you will give back to us as questions and feedback later on. So this is Jan Weidenhaupt and me. Jan just finished his studies of computer science some time ago, is working as an application engineer at Öffentliche Insurance Company in Brunswick in Germany. And next to his Kotlin work, he's doing a lot of work in Java, Scala. He's interested in Go and Docker. And as you may guess, I'm a few decades older than Jan, and I'm the head of IT architecture at the same company. And next to my Kotlin work, I like Scala and do a lot of work in Spring and Kubernetes these days. So today, we would like to show you how to build a chat app in Kotlin using fritz2 and Ktor from scratch. So the first thing to do is to show you the app we want to build. Just start it in the IDE, and voila, here it is. Just a simple chat app. On the start page, you can create a new chat, give it some name and enter your own name, and then join the room. And of course, you can join this room. Sorry, I have to find the right window. By sharing a link. Go back and join the same chat, and I will disguise as Jan, and now I can say something. For example, and now I get the messages here. And we can continue to write our messages to each other using this chat app. And of course, this is responsible. So you can view it on a mobile phone or something like this, but does still the same and does not too much, but it will hopefully be perfect to show you how fritz2 works and how it works together with Ktor in the backend. So again, have to find the right window. Here it is. Okay, to get started, we have built a small template project in GitHub. You can just open the project and use this template by clicking this button, and then you can create a new project at GitHub. And this template will set up a complete Kotlin multiplatform project for you, so you don't have to think about dependencies for using fritz2 or anything else you have to do to set up your Gradle build. One of the great features of Kotlin multiplatform is the ability to share to put all your code for your backend and your frontend in one project. So the structure for our example will be the following. We have the common main source set where you put code that will later be used on the backend running in the JVM, and as well as in the front end that is compiled to JavaScript and will run in the browser. So you have to write code for this, for the data model, for validation, for serialization and things like that only once. In the JS main source set, you can put everything you want to compile to JavaScript. So the front end built with fritz2, your UI components, your theme, your styling, and things like that. And in the JVM main source set belongs everything that is building your backend using Ktor in this examples. For example, the WebSockets we will build in the REST API we will later use. So this is the basic structure. And now we would like to start. Fritz2 consists of only a small set of key principles you have to know to build a web app that defines how to build your app. And the most important one of all of this is certainly the circle of life. You manage all your application state in one or more stores. This is on the left side. And a store offers the current state of your application at any given point in time as a flow. A flow is a key element of the Kotlin coroutine library. I think many of you will have worked with this. And to create the view, you just have to map the state of your application, so the data, to some HTML representation by using HTML tags. And then you can use a mount point to mount this representation of text to somewhere in your DOM. Now, whenever the content of your store changes, Fritz will automatically update this part of your DOM accordingly. And the other way around, you can listen to events at your DOM nodes when building your HTML representation and map these events that are also offered as flows to some actions. So for example, you may map a click on a button to the removal of a certain element of a list or something like this. And these actions are then connected to handlers. These handlers are implemented at the store and know exactly how to update the store's data according to the given action. And that is all. So that is needed. You need no shadow DOM, no life cycle definitions for your UI or any other indirections. By defining which part of your application state is mounted to which point in your DOM, you automatically can set up a precise data binding that allows fritz2 to do minimal updates to your DOM. And it will automatically re-render half of your page if this is needed, or maybe just update a small single attribute somewhere deep in your DOM when this is enough to represent the change in your state. Okay, so move on to some code. At first we have to define our data model, and we do this by just writing a small data class called chat with two attributes, room and member. And the annotation you can see above at lenses causes fritz2 to create some code at build time. You can later use to access deeper parts in your data model. We will see this later on. So now we create a store just as a Kotlin object by implementing the root store abstract class and initialize it by giving it an empty chat in our case. You can see inside the store later on we will define the handlers. We will connect the actions to later on, and Jan will show this in detail in his part of the talk. Next we will create two substores, and a substore represents a certain part of the data model of its parent store. So a new value on the data flow of the substore will only appear if this part has changed in the parent. And this allows you to set up your data binding as precise as you want or need. The other way around, whenever you update the data in a substore, it will automatically update this part of data in its parent. And this will bubble up all the way to the root store. So you can see this in this diagram. To define which parts of a data model a substore should represent, you can use the lens objects that are created by fritz2 using the annotation, the lenses annotation you've just seen, and then parent and child, and also on. Next, we want to create the join page. You can see at the top. And we do this as a reusable UI component. And writing a reusable UI component in fritz2 is that simple. Just create a function, give it render context as its receiver. And of course, you can add some parameters if you want to control what your component will render. And then we will, in our case, the two substores we just created. And then we will create the single elements of our page. First, the stack up. Stack up is a component that just puts everything in a vertical order. And as items of this stack up, we will add an image, just the normal image HTML5 tag. And as you can see, you can add set every HTML attribute at any given tag by just calling the available methods. Now we add a form control and an input field inside this form control. A form control can do much more than you can see here. You can add a label and validation messages and so on. And an input field is an input field. And by just setting the store parameter to our room store, we implemented two-way data binding. So whenever we type something in this input field, the data in our substore will be updated and the data in our root store, of course, accordingly. And other way around, whenever our application state changes, the value attribute of this input field will also change. We give it a placeholder and do the same for our member field to enter our name. And finally, we add a button and give it some text and an icon. And now connect this button to the handler you've seen before, the join handler at our chat store. So whenever you click on this button, this handler will be called without any payload or parameters. In this case, it's just simply clicking a button and then join a chat. Okay. The components like stack up, input field, etc. are part of our fritz2 component library. And of course, you can do all this by just using the core of Fritz and HTML base tags and maybe some CSS framework like Bootstrap or Tailwind or whatever you like. At this point, we have to warn you because the version 1.0 of Fritz2 that we hope to release in January next year will have some major changes regarding styling and components. But for now, this is what we use to build our applications. Okay. Next step is setting up the validation for our form. Remember that this will be defined in the common main source and will later be used by both front end and back end. To do so, we create a chat validator inheriting from an interface component validator and just implement one single method that is called validate. You get an inspector as a parameter of this method. And this inspector you can use just like a store to navigate through your data model by calling sub and using the lenses exactly like the store. And it handles things like IDs that are added to the text, so you can later create corresponding error messages to the elements of your UI. And now you just build a list of some error messages and implement the rules of your validation. Of course, you can build error messages or info messages and give them the text and the path to your element. Using this in the chat store is also very simple. Just add with validator to your inheritance and then implement the validator attribute and let it point to the chat validator object we just created. From that on, every input you make can be validated by just using this validator and, for example, checking if the current state is valid and react to it however you want. And finally, in the main method, of our project, we use a chat theme we built for this application, render a component called app frame, and this provides you with the basic layout for a web app with the navigation on the left and some other sections. And in the content section, we just call the component we created, the join page, for the room store and the member store, and this leads to the rendering you see above. So what is left for us to do is to create the chat itself. To do so, we just write another component function to display one single chat message, as you can see above, and two more to render the timestamp and the sender. And just build it together. A line up is just like a stack up, only horizontal, not vertical. We add some styling like margins and alignments and font sizes and whatever else we need, and call the other two functions from here. And then we render a div, basically style it with some shadow, background color, etc., and just render the message content. Whenever you want to create a text node as a subnode, just use the plus operator. And then you can implement the send from, basically the same, add an icon from our theme, the user icon and the member name, and at last the timestamp, also the same as span and an icon, and just render out the time you want to show. So this is basically the messages that are sent by our own, and the messages we receive we want to style a little different. So we check if this is we are sending this message or have sent this message by ourselves, and if so, we want to position this on the right, those two, else on the left, and also we change the background color from primary base color to secondary base color. Those colors are defined in the theme and can be changed there, of course. And finally, we have to create the chat page that shows the whole course of our chat, rendering all the messages from the list. So we create a stack up to align them vertically. And so here you can see the data model. We have all messages in a list as an attribute messages. We create another substore accessing these messages by using our lens. And now we call a method called render each, and this causes Fritz to watch the list we just pointed to, and it causes Fritz to absorb all the changes to this list in our chat store and to perform minimal patches that are necessary to represent changes made to the list. So in our case, we only will add new messages to the end of this list, and so Fritz will create just the nodes necessary to represent these new messages in the DOM when they appear. Okay, this is the structure of the substores, and finally we just render out the single messages, put them on the left side or on the right side, and call our component that we created earlier to render the single messages. Okay, and that is all we have to do, and we are done building our apps views. And now we have to set up the backend and communicate with it.
Yeah, so now we take a look at the communication between backend and frontend. And here I have a simple overview how it's handled in our simple application. On top we have the message API, which using WebSockets for bidirectional communication between backend and frontend. And And also we need some part where members can join our chat room on the left side, and also leaving when the WebSocket connection gets closed by a client, then it leaves the chat room. And also we provide a small members API where you can get the information of all current members in a chat room. So that's simply it. And now we want to look into the backend and how it's get implemented there by using the Ktor framework. Of course, we are using the WebSocket extension for Ktor 2 here, because we use WebSockets, of course. So generally, our chat room has a name or a key. Here it's a hash map, so our key of type string is our name of the chat room, and then we have a list of clients that were joining the chat and can chat there. And every client is also a member, of course, and have a name here, a member, and their own WebSocket session. And so in general, in Ktor, to handling WebSocket connection, we need an endless for loop for waiting on incoming WebSocket frames, so incoming messages, and then we handle them. And in the finally block, we are handled the leaving. So when some WebSocket connection get closed by a client, for example, we are going to the finally block, and then we handle the leaving, which I want to show you right now. So first we check if there is a chat room already. When if it's not, we create a new one. And then we have different message types for our chat messages. So every chat message contains the information if it's a joining message or is it a normal message. And for the first one, if it's a joining message, we inform every other client in our chat room that a new member is joining, and then we add them, and when it's a normal chat message, we broadcast them like normally. So that's all the code we need for it. And in the finally block, we handle the leaving. So every time a WebSocket connection gets closed by a client, we find the associated chat client and remove it from the list, and giving every other in the chat room a leaving message that they know that one client is leaving the chat room. And if there were when the list of clients is empty, we can also remove the chat room. So we can destroy it. So on the front end side, we're handling the communication fritz2 like by using stores. Jens already told us. First of all, we are defining our API endpoints here. The first one for our members is an HTTP endpoint, and our second, of course, is the WebSocket endpoint. Both is supported by fritz2 by default, so we write our own small API for it. And then we have our three different handlers, which handling the join, the receiving, and the sending of messages. So we will see next. First, we look into the joining handler. When joining a chat room, we send a message with the type joining, I told before, and then we connect the the messages sent from the server with our receive handler by calling the handle by function. And at the end, we return the new state of our store. So we joined the chat room successfully. And we load also the list of members. So next one is the receive handler. The receive handler at first takes a look at the message type, because when it's a message type of joining or leaving, we must update our members list. And then it simply appends our new created message to the list of messages that we already have. So that's very simple, and send is much more simpler. So we create just a new chat message from our text given in our input field, and also add our own chat member. So, and just send it by our WebSocket API. And then we also append the new message to our list of already received chat messages. So the complete code for our example, we only showed you the highlights of our code, but it's not much more to see. But when you want to take a deeper look into our example, you can do it by following this link. So everything is hosted on GitHub, and it's open source and free to see. So get your hands dirty if you want. We provided some, we have our own web page for fritz2 with some example codes, with documentation. Everything is hosted on GitHub, of course, and open source. So you feel free to give us some PR or some issues if you find them. We have also created some examples which you can start off with, and can look how fritz2 works and how it's like. So thank you very much. That's all. Hopefully we are in time, and maybe you have some questions for us.